kidding. Don't worry.
Merit.
Just kidding, that makes it okay.
Merit. Merit.
Yep, there is. How many more chapters? As many as we can.
Because there's no final, so we're
I'm
just
running out
going
of
to
space.
test.
Wait, there's no final?
Oh my goodness.
Why am I learning then?
Yeah, let's go.
There's no final? Why am I learning?
A capacitor, okay, is a device that is used to store electrical potential energy. It does not create electrical potential energy, it's used to store it. So in order to use a capacitor, you have to put the potential energy in the capacitor. Okay? An example of a capacitor is really just a charged plate. So say if I have two charged plates, I'm going to take a battery. I'm going to connect it to the two plates. The battery will take the charges and displace them. So what will happen is one will become negative and one will become positive. Because the battery is doing work to get the negatives to move from one plate to the other, leaving the plate that the electrons left from to be positive, and the plate that the electrons go to become what? Negative. Okay? So a battery is used to charge. It's not the only thing that charges a capacitor, but the most common example of charging a capacitor would be to plug a battery up to it. So what will happen is the charge of the capacitors will stop charging when the potential difference between the two plates is equal to the potential difference of the battery. Okay, because essentially the battery is pumping, is doing the work to get the charges to move so that there's a potential difference. You're never going to have a potential difference on the plates greater than the object that's charging it. That should make sense, right? Okay? If this is a 9-volt battery, your plate should be 9 volts. When it stops, because if I don't have the power to cause more charges to be displaced, it will stop. Okay? Then what can happen is I can take the battery off. Okay? And since these aren't touching anything, it will store the what?
Energy.
It will store the energy in the form of displaced charges. Then I can take this capacitor and I can apply it to a, let's say, a light bulb. That's a nice light bulb. This is how you symbolize a light bulb in circuits. Okay? So what will happen is the electrons will flow once I've connected the capacitors to the light bulb. The electrons will flow, causing the light bulb to light up, and the light bulb will stop after all of the charge has dissipated. Okay? Eventually, these charge plates will reach the same charge. Right? Because all the negatives will come back over here, eventually making it where the charge will be completely dissipated and you have no charge on the charged capacitor anymore. Okay? So, the purpose of a capacitor is you can charge it with an object, typically a battery. There's some other things that you could use to charge. Okay? It creates a separation of charges. Then you can take that power source off, like a battery, and you could use that capacitor as a temporary power source. No, because a battery creates charges through a chemical reaction. They're very similar. Actually, I looked up I wanted to make sure that they weren't the same, and I looked it up just today. Because in my head I was thinking, well, a battery would be like a capacitor then, right? Well, it's not completely different. This cannot create charge. It has to be charged. As where a battery has a chemical reaction that creates the charge.
Would a rechargeable battery be a capacitor?
I still don't think so. I'm guessing, well, because I think it's just, it uses the concept of a reversible reaction where you can cause it to go backwards to a certain point and then reuse it. So I still think it's a chemical reaction. Yeah. How electricity is used to cause a reaction to go reverse, I don't know the answer to that. Because usually you plug a rechargeable battery into like an outlet. Yes?
Could we do an experiment where we stick a fork in a toaster?
Fork in a toaster?
Yeah.
You're always like, what?
But like from far away, so we don't get hurt.
But like the metal ones, like this.
Should we use a battery to cook a hot dog?
Yeah.
Should we change a light bulb?
Connect wires to forks and pop them into the hot dog and see does that cook a hot dog?
Or if we change the light bulb and saw how many equals of.
You should take a dead battery and then replace the solid.
Okay, so a capacitor is the object that you can use that can store charge. Capacitance is how well the capacitor can store charge. So if you have a high capacitance, that capacitor can hold a lot of charge.
And then
Or it can have a lot of potential energy and a lot of potential difference then.
is your phone battery a capacitor?
I don't know. I do not know.
Yeah, but that's like extreme.
Oh, the fact that it's a battery? Oh yeah, it's a battery, it's like a big capacitor. However, there are capacitors in your computer, specifically your keyboard. And we'll talk about that today.
I know there's
Is this
mechanical? Because a battery it can produce charge through a chemical reaction. Batteries have chemical reactions.
Like a phone battery. Is that all?
I'm pretty sure all batteries are. Okay, so the SI unit for capacitance is a farad. F, also known as a coulomb per volt.
They're all so similar.
Yeah, I know. They have. We're starting to get into the weeds of a lot of derived units that are derived from each other. Okay, so here's your equation. Capacitance, we said, is the amount of charge that a capacitor can hold. And so it's the charge per potential difference. Right? I think we're getting a couple of equations.
How is like, wait, how is potential? Like per one.
It's not, well, typically you wouldn't have this be one. You would have a certain charge, which is like 4.3 potential difference, and then you divide it by that to get your, so it ends up being what the charge is for every one potential difference.
Is that different than like lowercase? Is that still?
I mean, it's still charge, but it's talking about charge on the plate. If that's the difference. Yeah, as far as why it's capitalized or lowercase, I don't know why they capitalize it. Okay. Okay. Now. Okay, it says that capacitance depends on size and shape. Okay, why do you think the area of the capacitor affects its ability to store charge?
Because the more area, the more room for charge.
Yes, essentially, right? Because if you look at those two capacitors, right, the smaller the area and the more charges you have packed in there, you have more repelling, right? More repelling is going to create more potential energy and a bigger potential difference. Okay? So if you have a bigger plate, okay, it can store more charge because those particles are going to be further away from each other. And so you're not going to have as strong of a repelling factor.
Well, I'm just saying, with
wouldn't that make the distance?
It's saying distance between the plates.
So you're saying, oh, as it.
So distance is the distance between the plates.
So you're saying as the distance increases, it like the overall capacitance decreases?
As the distance what?
Like as the distance increases, the overall capacitance decreases?
Yes.
That would make sense. Right?
Yep. Yep. So as the distance between the plates goes up, the capacitance goes down.
Okay, that makes sense.
Okay? I have no idea. I mean, I don't really know what the significance of that is. Okay, it's probably just some constant that needs to be in there for the unit to work out.
Yeah, that'll probably be this.
Probably.
Permittivity of
Okay.
medium.
So, as the area goes up, your capacitance can go up because it has more ability to store more charge. As the distance between the plate goes up, the capacitance is going to go down. Inverse for that.
Coulomb squared divided by a meter times Newton times a meter. That's just the worst.
Because then you can break coulombs.
All right. Now, in this class, we are going to assume that when we're doing capacitors, that there is no such thing as a dielectric, or we're going to assume it's done in a vacuum. Okay, a dielectric is any material that has charges in it. Okay, and what happens is
So everything.
everything. Well, anything. Like even the air can act as a dielectric, but it's not a very good dielectric. Okay, so what a dielectric is there's always going to be something in between the plates. At the very least, air, right?
Right, sure.
Could I put other materials in between the plates?
No.
Sure, not.
You could, right? You absolutely could. Okay?
No.
And each of those plates has different properties based on its ability to allow charges to move. Okay? And so what ends up happening here is, we said that there was an electric field in between here, created by these, right?
Yes.
Right? And if I have substances in between here that have charges, is that going to affect the field?
Yeah.
Yeah, absolutely. So what ends up happening here is the negative charges on the substance in the middle is going to be attracted to the positive and vice versa. And won't these negatives reduce the field of this or make it lower?
Right.
Yeah.
Yes. And wouldn't these positives reduce the field of this?
Yes.
So what the purpose of a dielectric is actually you can charge the capacitors more. Because it reduces the field and it reduces the potential energy. Because if these negatives are here, okay, there's less potential energy on here. Because of the negatives attracting. And same thing here. So when you have a dielectric in between, what that does is it allows you to charge the capacitor more without changing the potential difference.
Is that what you?
Wait, you want less potential energy for the capacitor?
Well, yeah, you can remove the dielectric,
So.
Okay.
right? You could use a dielectric to charge it more and then remove it.
Yeah. Okay.
Definitely a part of the sensitivity, like.
It does now.
Absolutely. So, well, okay, it has a part. Okay, so I do want to talk about this. This is a red sheet. I think kind of cool.
Brain keyboard.
And so here's your dielectric. Okay, it's I don't know what the dielectric in the keyboard is made up of, but it's some material that when you push down the key, it compresses the dielectric. That changes the capacitance. So whether you've got an electrical chip or something in your computer, that when it notices a change in capacitance, it says, "Oh, you push this button," and it shows up on your
So what about like,
computer.
what about how like phone chargers nowadays are like, don't even have to plug them in?
Those have like a. I watched the thing about it. I can't.
Those are the brains. Yeah,
Wireless
wireless
charging.
charging, it's insane. I don't know how it works.
I know what you're talking about, but I don't know how it works.
It like.
It's like space. Also,
Space magic.
so like, would that be
It's
like,
pretty useless
you know,
because we
sometimes
have
they're
to
like
have
advertised,
I know,
like,
yeah.
it's chargers like that.
It's cool for cars though, because like you can put it in parking spots and then just park.
I don't know how they would do it through without touching them,
It's
right?
like-
Because like
Yeah, it's nice.
this is all the capacitance of this is all through touching.
Yeah. No, I'm saying like if it was, if it is a plug-in, that's how they like.
It's like.
Always charge faster.
Just
plug it in.
Yeah, you go like dialects.
It's like inductors.
It's not a
No, this dielectric is usually
The material is.
for capacitors. When you plug it in, you're plugging it directly to an electricity source.
So they just make it a better.
So then it says the effect of dielectric So is the material what's dielectric?
Yeah,
It's a
but it
direct
could be
shot.
any material.
I mean, when you plug your phone into an electric outlet, electricity is flowing straight and quickly right through a conductor to your batteries. I don't know all the inner workings of batteries, because batteries, there are different kinds of batteries.
Lithium batteries, like lithium ion.
There's
like
a cell
batteries.
battery.
I think it's cool, but the problem is there's so many different types of things, I don't know every little detail.
This is what my dad said he was gonna do.
I find this stuff fun too. Like, if I were to not be a teacher, I think I would really like being an electrician.
Yeah, my dad was gonna. He said that the reason he did was because he went to college, he started engineering. His engineer was a civil engineer. He hated civil engineering, so they just kind of so it's probably like wizard brains.
Okay, so let me ask you, why would these two plates compressing this, why would that change the capacitance?
Because they're closer.
It increases it because the distance is smaller.
Distance is smaller, so capacitance goes up. Okay, and you've got an electrical chip in here somewhere, I don't know where in there it is, that detects that change in capacitance and sends a signal that says, I clicked the S key.
So what you're saying is, as the capacitor,
That's why I'm not good at Fortnite.
become a faster Fortnite.
Memory keyboards are gross.
Alright,
Keyboards like this.
so this is just saying how you determine the potential energy stored up on the capacitor. The charge times your potential difference. Okay, so I think it was a modified version of that version.
After I said that, I realized that.
Modified.
Okay, because didn't we say that potential difference was very similar to what?
Potential energy.
Potential energy. Okay, so the last equation, there's some derivations that go along with it. I don't know the derivations off the top of my head. How you get from that previous equation to this one, I don't know the answer to that. Okay? What? Okay? Is that a problem? So, let's do this. Okay? Things to get out of this chapter. A capacitor does what?
Stores energy.
Stores potential energy as a result of charge distribution. Okay? There has to be some power source that charges the capacitor. You then can remove that power source and you will have those charges separated. They're not going anywhere unless you connect them to some conducting material. You then could use those charged capacitor to power something for a short period of time. So there's actually some advantages and disadvantages to batteries and capacitors. The advantage of a capacitor is it charges a lot quickly, but it also discharges.
If you run common error, it charges a lot.
It charges a lot quickly.
It charges.
Anyways,
It works.
do you guys understand what
Yeah,
Does
yeah.
my mess up in words
So judgmental.
confuse what I'm
On
trying to
tests,
sell?
yes.
Not really.
It's not good also.
Yeah, testing quizzes.
But that's not usually me that works in weird.
And you.
Speaking of weird worded tests,
Oh my word.
So you're saying.
saying college comp, we got to all
Oh my
take this
gosh.
test, and we all got like the same answers wrong because we were right and the test was wrong, and we literally like showed the evidence from the book. Like,
Word for word.
Like word for word that
Sounds
we were right,
like
and
it
then this is
literally
after
said
like,
that friction
nope,
was not a
false. Like
Yeah.
it literally said the book said.
And then she looked at her packet and then she's like,
and
oh,
Mildred
that
turned
is
in
the
the
right
alarm
answer.
against
My bad, let me change
Montag,
that.
and then the question was, who turned in the alarm against Montag? And then Mildred
She's
was
like, it wasn't
nope.
her. Like,
And then
Did
she's
you
like,
change it later?
No,
No.
she
She
changed like,
changed some of them.
That's like that one-
point
she changed 2 for us.
No, her
That's like
evidence
that one
was
time
that
when
she
There has
put
been
first.
times though,
How do you?
I will say,
No.
the student thinks they're right when they're really
No, 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 I was
No.
Kramer, that's like
Don't.
that one time when the book said the friction wasn't really a force.
It was your interpretation of the book.
It's like that one
Remember that.
time
Screw
when
books.
we had the
Alright, here we go. Let's do this problem here. Okay? So, we have a capacitor. Okay, if you connect, listen. Ignore what you guys said.
It was on
A
camera.
capacitor is connected to a 12-volt battery. If you connect a capacitor to a 12-volt battery, the charge or the potential difference on the capacitor will be what?
12 volts.
12 volts. It will stop charging when the potential difference on the plate is equal to the potential difference of the what?
Battery.
Battery.
Capacitor and change.
Alright, so our change in V is 12. Alright? Then it says the charge plate holds 36 microcoulombs of charge. What that means is the positive and the negative, they're the same, right? One's just a positive 36 microcoulombs, the other's a negative 36 microcoulombs. Because what you're doing is taking electrons from one and moving it to the other. Or this way.
But we just used one.
Well, yeah, because that's the overall charge between the plates. Okay? So, what did I say? Q. Yep, sorry. We should probably do 10 to the negative 6, huh?
Yeah.
Okay? Find the capacitance of the plate and find the potential energy stored up on the plate.
However, are you gonna do this?
Are you being sarcastic or serious?
1/2 Q.
What equation are you going to use to find the capacitance?
The capacitance equals Q divided by Q.
I would ask learn the potential energy electric first.
And which one are you going to use to find the potential energy?
E electric equals 1/2 Q change in V.
Oh my words, magic!
Isn't that change in V squared?
Magic. And that's the one I was
Oh, okay. There's another one. I want you to get this one too. You guys know how to put this in your note card?
You got to put it on the side. Well, there's so many equations.
This equation is this substituted into this.
Great. Let me think about it.
Oh, okay, then we can
So
just
move
use that
this,
equation.
so you'd be plugged Q in here. So
Oh,
what you would have would be CV squared.
as you know, so you're putting my charger.
Now, I really probably don't need to give you this because all you would need to do would be to find
Q and
Q and just plug it in. Yep,
Is it the change of V that's just squared or all of that?
just change in V.
Did you say?
Do you see how this would work if I were to solve for Q? Plug it in, you have 1/2 C change in V times change in V. Alright, what'd you guys get for your answer?
I got
I calculated
112.
My calculator is
2.5.
36 times 10 to the negative 6 is my charge. My change in V is 12 volts.
Yeah, so I got 3
That's not the equation.
3 times 10 to the negative 6, and the unit is?
F. Newton, Coulomb
Farad.
Wait, what is that?
bar quads.
What's what?
Which answer? That's
That is the capacitors.
And then, did you want us to do the
frustration.
Okay, and then you are trying to find your potential energy here, which would be 1/2. Your Q we said was 36 times 10 to the negative 6. And your change in V is still at 12 volts. And so what you get for that is what?
2.16 times 10.
22 times 10 to the negative 4.
Whoa.
That's correct.
And that should be your potential energy, which will be in units of joule. Okay, now don't get too overwhelmed with the units here because there's a whole bunch of derived units in this particular lesson or this particular chapter. So just know that if you're in your most common unit to begin with, you're going to get your most common unit out. For what I mean by that is a joule, right? If I have my Q in in coulombs and my change in my potential difference in volts, those are your most common units for those variables. Your answer will be in its most common units.
We have a bowl today.
We do? We'll probably use most of next week.